Okay, so we're doing the AP Stat Quideo number 2, the basic question. So here are Professor Moore's times in minutes to swim 2,000 yards and his pulse rate after swimming in beats per minute for 23 sessions in the pool. So up here you can see that they give you the time and pulse rates. So for part A, verify that a linear model appropriately models the data and state the equation of a linear model. So to do that, you're going to go to your calculator and do stat, hit edit, and put in your data for L1, L2, and it's always a good idea to double check that you entered in your data correctly. So second, y equals, turn your plot one on, which mine is already on, and then the type, it's already on the scatter plot for you. So then you're going to go into zoom, go down to zoom 9, which is zoom stat, and then here you can see it gives you a nice graph of what the data looks like. So to verify that a linear model shows the data appropriately, you can kind of like estimate where a line would be on the calculator if you could draw one. So the second part, stating the equation, so that is referring to the linear regression formula, which is y hat equals a, which is the y-intercept, plus b, which is the slope, times x. So what you're going to do is you're going to go back to your calculator, do zoom, go over to calc, go down to number 8, which is the linear regression, and then you're going to hit enter, 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 and then here it gives you your a and your b, so what you're simply doing is plugging those numbers in. So then that is going to translate to y equals 479.9341 minus 9.6949 times x. So then part B says, the next day's time is 34.30 minutes. Predict the professor's pulse rate. His actual pulse rate was 152. How accurate was your prediction? So to solve this, you're going off the equation that we found in part A. So y equals 479.9341 minus 9.6949, and your x is the time that they gave us, which is 34.30 minutes. So then you're going to plug that in, and then you can go back to your calculator, and when you do that, your answer is going to be 147.39903. So the professor's pulse rate for the next day is 147.39903 beats per minute, also known as BPM. The prediction was 4.60097 beats per minute lower than the actual pulse rate of 152. And so to figure that out, I just did 152 since that's what they gave us, minus our answer to get the 4.60097. Part C, suppose you were told only the pulse rate of 152, you want to predict the swimming time. Find the equation of the least squares regression in the line that is appropriate for this purpose. What is your prediction and how accurate is it? So what you're going to do is they are basically switching the explanatory and response variable. So to do that, since you already have all of your data in your calculator, all you're going to do is go back to calc, go back to number 8, and here they're switching it. So for x list, instead of being L1, you're going to do L2, which is second 2. Then you're doing that for the y list, so that would be L1. Hit enter, and there it gives you your a and your b. So then to translate that, the equation of the least square regression line to predict the swim time is y hat equals 43.0972667 minus 0.0574 times 152, since that's what they gave us. So my swim time prediction then results to 34.3725 minutes. Then going back down to D, for this question, explain clearly to someone who knows no statistics why there needs to be two different regression lines for part A and C. So the easiest way to explain this is there has to be two lines because someone may view the cause and effect differently. So in this case, in part A, we viewed the time to cause a change in the pulse, but in part C, we looked at it oppositely. We saw that the pulse changed the time of the professor. So it all depends on what someone views as the explanatory variable, which is what causes the change in the other variable.